studying hard would get to be able to imagine these things like I imagine. Of course, I was an ordinary person who studied hard. There's no miracle, people.
Hello, hi guys. I'm Michael. I'm Michael Winner, and I'll be talking about databases today. What we have here today is what is the database, what is the DBMS, flat file, the strong idea, and then what are the guarantees of a DBMS, right? What are the guarantees offered by the DBMS, right? So yeah, let's get to it. So first of all, well, let me throw you a question. What do you understand by a database, right? So in my let me give you a very good definition, right? A database, a database is an organized collection of interrelated, right? It must be interrelated, right? Interrelated data that model some aspects of the real world. So what does that mean? What does this that models some aspect of the real world? What does this mean to us? So yeah, it means that for example, let's just for example, a music digital store. Oh yeah, a music digital store where you have the name of the artist, right? So let's say Omah Lay, understand, and then year 2021 or something like that, and Asake, great guy, that's the name of the song, and that's in 2022. And then we have Olamide, Baddo, or something like that. That's in 2023, and I know. So this can be what we refer to as a collection, right? Organized collection of interrelated data that models some aspect of the real world. What can we say? Yeah, they are organized and all. So and yet example of databases. So this is where the whole thing is common. People confuse database with DBMS. Database and DBMS are two different things, right? So example of databases, right? Example of databases. e.g. It's not Progress. Postgres is not a database. Postgres is a DBMS. So e.g. we have your notebook. Your notebook is here. The hard disk. You hash tables. Yeah, hash tables. And then we have dictionary, and we have your journal too. Yeah, let me say them. Your journal is a database because you store data into these things, right? So they are databases, right? And so let's go to what a DBMS is. What's a DBMS? From the name, so a DBMS, that's a database management system. Right? What does this do? From the name, right? It manages the content of the database, right? Of the database. So example are Postgres, MySQL, then ClickHouse, Apache Pinot, and stuff like that. So these are database management systems. So what can we say about them? They define the set of rules to write, to read, updating the content of the database. This is also based on the data model. So we talk about not updating, update, and read and update, and delete. Update and and delete the content of a database, right? So let's put of a database. So this is based on some data model that we'll talk about right now. So but before that, right, let's talk about why do we need a database? Why not just using our file system, right? Why not just using raw files, right? Why not just using raw file? Why not just using a flat file, raw file, right? Like normal file in your. So this is the Stroma idea. Well, why do we need a database? Why not just use a flat file? Why not just use a flat file, right? That's the Stroma idea. What does the Stroma idea say is that put the content. So the example of this, right? This music digital store that we have here, I can store. So let's assume this is a comma separated value. So music digital music store does see. So this is a CSV file. So and this is the content of the CSV file, right? So content of the CSV file, and then I have Dunsin Oyekan too as well. Dunsin Oyekan. Nayu, right? I know it's Nayu. I then that was in 2017 or so. So yeah, this is a flat file, and if you want to read the content of this file, right? So if you want to read the content of this file, what do you observe? What do you think? If you want to read, let's say you want to play, you want to read Dunsin Oyekan, you have to. So I'll write a pseudo code here. So a pseudo code is for hen in hen file dot read line. This file dot read line, read each of the line, right? And it starts. So there's a loop, right? You read each of the line one by one. So so n is equals to Dunsin Oyekan. You read each of the line and then you pass. Let's pass line. So let's pass line value is equals to line dot pass. You pass this value, and then Dunsin Oyekan, you say that the hen values, the first value of this is equals to Dunsin Oyekan. So until it becomes Dunsin Oyekan, then if this is Dunsin Oyekan, then the next thing you want to do is the next thing you want to do is to what? The next thing you want to do is to print the title, so something like that. Title is what values and then that's the first value. So that's it. So now imagine you want to what's it called, you want to read, let's say this is a billion record, like the music store is a billion line, right, inside a single file. So before you scan, you have to scan it one by one. So problems of the flat file, right? Problems of the flat file, or from an idea. What are the problems? Number one, you have to linearly scan each of the file, each of the line. So that's O of n, right? So billion record. Imagine billion record. You don't want to do that, right? And then what's it called? So for example, now let's say that you want to add you want to have a different artist on the same album. That means you have to do artist 1, artist 2 again. You have to redesign the whole CSV file, which is daunting. Everybody knows that it's daunting to have, and you don't want to do that, trust me. So it's and then what if, so another problem is that if two people are trying to write to the same artist at the same time, to the same line at the same time, so concurrency issue, writing this doesn't guarantee concurrent right, it doesn't at all. And then durability. Well, what about the durability of this file? What if I'm trying to write to this file, to this CSV file at any point in time, and then probably is any power issue or something, the old laptop went off or something, the old laptop goes off or something, then the durability is not guaranteed. And durability isn't guaranteed. So those are the problems that we have with the Strawman idea, the flat file, right? And that's the whole issue with Strawman idea, flat file, and then the file system, right? So you do not want to have anything to do with the operating system. Operating system is to database engineers, the operating system is a frenemy, right? The frenemy, right? So we'll get to talk about it in the whole series, right? But this is lecture 1. Why do we need a database and whatnot? So and then that's the database engineer, the operating system is our frenemy, is our friend and enemy at the same time. So you have to be cautious when you're interacting with the operating system, right? So then what are the guarantees of the DBMS? What does the DBMS guarantee? What does it guarantee for us, right? So the guarantees of a DBMS, of a database management system. So we have issues with the flat file. If the flat file can't serve us all these issues, so the DBMS should be able to work, should be able to give to us, and that's where we have the properties of this thing. So we have atomicity, right? What does atomicity mean? The other time we mentioned that flat file, if you are trying to write to it at any point in time and there's any power issue or your system goes off or something, then you have corrupt data. Alphas will be written and alpha will not be written. Like it will. So that's not what we want. So this guarantees that all of writes is written or none is written. So that's one of the guarantees, right? Atomicity, and then we have durability. Durability means that if the DBMS tells us that this is written into the disk, it is written into the disk, right? If I say that a record is written into the disk, then take my word for it. Take my word for it. That's what the DBMS is telling us, right? And then isolation, right? Isolation. Or what does isolation means? Isolation means that if two users are trying to, for the example of the flat file that I was telling you, that if two users are trying to write into the same record at the same time, the file system does not guarantee that. Or your Excel, right? Your Excel, if you work with Excel, the file system does not guarantee that. I will have to wait for one to. No, it does not. So isolation guarantees that two writes are independent of each other, right? They are not. And then and we have consistency. So consistency is that, okay, yeah, so one of the issue I didn't mention about the flat file is that the flat file, there's no, even if you have some set of rules, you have to have it on the application level, not on the database level, and that's one of the issues that you will face. So consistency means that if I give my database set of strict rules, right? So set of rules, right? It guarantees me that, okay, I will make sure that this is it. This works fine the way I want it to be, right? So guarantees that all my rules are enforced at any point you are trying to write to the database, right? So that's what the DBMS is trying to. So these are the guarantees that the database is trying to give to you. So people call it ACID, right? ACID. So we call it ACID, and that's atomicity, consistency, isolation, and durability. So, right, I believe right now you should be able to understand the difference, right? So you should be able to understand. I believe right now you should be able to understand the difference between database, DBMS, right? DBMS, database management systems, issues with flat files, issues with flat file, issue with flat file, and then we talk about the guarantees of the DBMS. So next time I'll be talking about data models, type of databases, type of DBMSs, and then file, and then we talk about relational algebra, third chord, and a little bit of history of Codicil, little bit of history of Codicil. I say why hell, something like that. So we'll talk about that in the next video. So yeah, let me know if you have any question. I believe with this I'm able to convince you, and then let you know why DBMS exist in the first place, why all these things are really important for us to know as software engineers and all. Yeah, so that's it. See you in the next one.